Good afternoon, everybody. I think everyone got very quiet all at once, like very punctual at 45 after, so I think that's my cue to start. Welcome to Using Docker for Development. I'm Laura Tajo. I'm the Director of Engineering at CloudBees. I came to CloudBees as part of an acquisition. I've been working with CodeShip or on the CodeShip product for over 3 years now, which has been very exciting to work for a small developer product that's now grown and has a very exciting future. I'm also a Docker captain, which is a title that's been bestowed onto me from Docker and the Docker community. So being a Docker captain is sort of a designation that I've been working with Docker for a very long time, and particularly I enjoy helping people, especially people who are just starting out with Docker, just learning about the power of containers. So if you are here because you've heard about this wonder of containers and want to know how to use Docker for development but haven't quite tried it yet, or you've tried it and you're looking for some pointers and practical tips, you're definitely in the right place. We are going to start at the very, very beginning today, which is containerization. If you have seen this trail map before, it's become pretty popular over the last year or two. This is the Cloud Native Trail Map that's maintained and published by the Cloud Native Computing Foundation, which is an open source governing entity that oversees a lot of the open source projects that go into tools like Kubernetes and Docker itself. So if you're trying to get to this horizon that is cloud native, this is a guide to sort of help you on your journey and help you understand what sequence to follow in order to get there. And containerization is number one. So you need to have your source code running inside of containers in order to enable all of the fancy tools later on, like using Kubernetes and Helm and other more sophisticated orchestration, application definition, observability analysis. All of that needs to have containers first. Notice that this is containers and not microservices, and that's a very important distinction. If you've been maybe hesitating to get started with Docker or containerization because you think you need to use microservices, I think it's really easy to have been convinced that's true, but it's not true. You can use containers for microservices, monoliths. It's really architecture agnostic. Well, we're going to focus more on the nuts and bolts today of actually how you get your application running inside of a Docker container and how you can use it in your development workflow. We'll go over 3 main themes today. First is going to be Docker Compose basics, understanding like when you run what command, what's actually happening, how does it get there, what do you need to be responsible for, what can you use that's already predefined for you. We'll talk about optimizing images and taking advantage of things like the Docker cache. And then we'll go over debugging in containers, because as a developer, it's really important to not lose your ability to debug and see things like logs when you're working in your local development environment. So let's just get right to it and start talking about Docker Compose. Chances are you've heard of Docker Compose before. It's a very popular tool. The reason that I'm picking Docker Compose specifically when I talk about Docker and development is because we want to pick a tool that's going to help us be the most efficient. So on one hand, there is sort of 2 low-level tools, and that would be interacting with Docker directly. You don't want to do things like have to build the image every single time you make a code change, or run a bunch of one-off containers by hand and sort of have a messy, messy terminal and Docker run commands that are wider than your terminal is. That's a good hint that you're doing something that's maybe a little bit too low level, and you need a tool to help you manage a little bit of that chaos. But on the other hand, we have tools that are way too complex, or workflows that are just a little bit too sophisticated for what we need when we're talking about development. For example, we don't want to have to deploy every single code change in order to see it in our browser. That's not very efficient. We might not need to set up things like a multi-node cluster if that's your production environment. You don't really need that in development, so let's not do that. It's a little bit too complex. And if you have an open source project or your project that has like a README that takes up 5 browser windows, that might be a sign that perhaps the development setup is a little too complex. So Docker Compose sits right in the middle. I think it's a really, really great tool as a developer when you're using containers. It gives you an app declaration that's based in YAML. It's really easy to read, really easy to edit. You can do things like access logs. You can mount source code inside of your container so that you can instantly see the changes that you've made. And it's really common. So if you go on GitHub or whatever SCM is your choice and find an open source project, there's probably going to be a Docker Compose file in it. You can start that application stack with a simple command, Docker Compose up, and it's kind of become the de facto standard for development tool for application stack using Docker. So that's what we're going to use today. I'm going to narrate this, this talk with a lot of examples and a lot of live demos. So I haven't really sacrificed to the demo gods like I usually do, but fingers crossed that everything goes well. In case not, then you can see me do some debugging on stage, which is stressful for me, but hopefully very enjoyable for you. So if you've ever caught a DockerCon keynote or been to DockerCon, you might have seen this app and it looks a little bit familiar to you. This is a really, I don't want to say it's a simple app. It's really over-architected just to like prove a point that you can have microservices with Docker and use a lot of different languages. But it has a really simple purpose, which is just to vote for one of two things. So this is a cats versus dogs voting app. And it has 5 services, but we're going to focus mostly on just 2 of them. There's the voting service, which just shows you the little buttons. Then there's the result service that shows you the breakdown of the vote tally. All of that source code is, I have it in my GitHub repository if you want to clone it. There's kind of some other examples from other talks I've given. There's a lot of stuff in there if you're interested in following along. So like I said, this is a little bit over-architected, but it is to prove a point. So we have a voting app that's writing or like enqueuing something in Redis, which is then being picked up by a worker that's written in .NET, which is then writing to Postgres and then being picked up by a Node.js application that's running our results app that shows the percentages. So very simple purpose, but kind of over-architected to prove the point that we have everything is written in a different language. And the really interesting thing is that this source code hasn't been updated, I think, since 2015. So the Docker Compose YAML file has been updated, but the actual source code has been written a couple years ago. And it doesn't need any updates in order to continue to work or in order to work with Docker, which I think is great because honestly, a lot of us, if you're not using Docker for development now, chances are that the source code that you're working with wasn't written in the last year. It's not this perfect, shiny, greenfield project that we all think everyone else is working on and we're stuck with legacy code. So this is sort of an example of mature code, a mature application. These top 3 services are the ones that we actually have source code to deal with. We're going to develop, build, and test those applications, package the code ourselves inside of Docker files. For these services on the bottom, Redis and Postgres, we don't actually need to do anything. We can just pick or pull the Docker files and the Docker images directly from Docker Hub. So we can just consume them as an end user by pulling them down, specifying the version, and then just running them in a container and making sure that the right ports are exposed. And it's a pretty seamless and painless developer experience. We'll talk about external dependency management when we get into the Docker Compose application templating itself. So that's a very brief introduction to Docker Compose and what we're actually going to do. And I think it's maybe great if we can just start out by seeing it working. So inside of my example voting app, I have a Docker Compose file. We have version 3. We have a couple services in here. So for every one of those boxes that I just showed, I have a service definition in here. So we have a voting service, and I have it's a Python app. I have everything in a vote subdirectory. Same thing goes for results. I have the worker here. And then Redis and the database, I don't actually have any source code for those, so I'm just going to say take the image from Docker Hub. I have a couple other things in here, like a data volume, which I'll talk about in a little bit, and I'm also declaring 2 networks. This is kind of nice because I didn't have to really write this file. It came with the repo. So as an end user, I'm just going to type Docker Compose up, and I'm going to pass in the detached flag because I'd like to have a tidy terminal and just see what happens. Docker Compose is going to go ahead and create all of those services for me. And I can head over to my browser. And just to show that I don't have any tricks up my sleeve, I took the application down, and now I'll refresh to show that it's truly just up and running now. And I have my application up and running. So I had one command as a developer, and I have my whole application stack using Redis, Postgres, .NET, Python, and Node. I didn't have to download any dependencies onto my local machine. And it's running. I can vote for cats, but change my vote because dogs are better, and see that dogs have 100% of the vote. And just make sure, do some QA that my application is working as I expect. I can change my vote and see that application or the result change. So everything is working just as I expected. So let's dig a little bit deeper and see all the other cool stuff that we can do with Docker Compose as a developer. The first thing I want to talk about is what actually happened when I pressed, oh dear. A lot of stuff happened. Yeah. Is this a great time to talk about how I really don't like the new MacBooks? Like, it's like dongle, it's terrible, the keyboard doesn't work. All right, no one breathe. Let me try, I'm gonna try turning it off and on again. It's a Keynote. I have a backup dongle, so we can try that. Cool. Pardon the intermission. Cool. If you could just stand there and hold it for the next 45 minutes,
Yeah, no problem.
That might work. Oh, wow.
Let's try from down here.
Works on my machine. I don't know. Looks good. It looks great up here. This is like a really unfortunate timing when I'm talking about using Docker because yeah, what happened? Okay, thank you. Cool. I guess while he's working on that, I can just give you some sparkling narration of what I would have covered. So what happened when I pressed or typed in Docker Compose up is that I'm issuing a command to Docker Compose to start the services that I've declared in that application file. I didn't actually start a Docker container myself. And I think that's one of the trickiest mental models is trying to figure out what level of abstraction that you want as a developer and like how to debug things and when something goes wrong, what's actually going wrong. So I'm interacting with Docker Compose and I'm basically delegating that container start event to Docker Compose. So Docker Compose says, hey Laura, you want a result service that's running Node? Okay, I'm gonna take this and I'm gonna fulfill your request by starting a Docker container. But I don't actually have to start that container myself. I interact with things on the service level. The same goes for Redis and for the database and for everything. The main difference between Docker Compose and a tool like Kubernetes or Docker Swarm is that Docker Compose is not in a reconciliation loop. So this is like a one-shot. If you start the container and the container exits, you have to go back to Docker Compose and restart and issue that Docker Compose up command. It's not like Kubernetes where it's checking the health and trying to bring that service back up online. So as a developer, this is what I consider a good thing because I really want to know if my container exits with a bad exit code and I want to be able to actually see what's going on. I don't want there to be some other controller in the background controlling up or down for me, unless I'm actually testing the, if I want to run it on Kubernetes locally because I'm going to run in development or run in production in Kubernetes, that's a great thing to do. But when I'm actually writing code, I don't really like that workflow. So, all right, we're going to try a new cable. So let's see. I shouldn't have made that bad joke about the demo gods.
So they're one of the two things.
Yeah. Maybe that slide was just like really upsetting. Okay. All right. That's fine. We'll roll with this and see what happens. So, like, this won't be a boring talk, certainly. So we have I won't go back to that slide because I don't want something to start smoking in here. But basically, it's just to illustrate you're issuing a command to Docker Compose, and then Docker Compose is telling Docker what to do on your behalf, and you don't have to manage it yourself. So that's great. We're interacting with Docker Compose, but there's still some other questions about, as a developer, what's my experience when I'm using containers for development? We're the developer here, the cool sunglass emoji, and this is the situation that we have and that we want to create just with using containers. I want to interact with the text editor and change source code, and then I want to interact with the browser and see the changes. Underneath that, what's really happening is like the text editor is, I'm changing my source code. The source code and the container are running my application, and then it's being reflected to me back in the browser. I want that instant feedback loop. I don't want to have to rebuild my Docker image every single time I make a code change. I want everything to be instantaneous. I also want access to stuff like logs so I can see output if I'm trying to debug something. Oh dear. Okay. I feel like maybe I'm stepping on something or just like my weight. Yeah. Oh. Yeah. It's like, my Sega, like as a kid, you hit it and then you blow in the cartridge. It's the equivalent of this. So accessing source code in a development environment where you're running Docker is made possible by this distinction that's runtime versus build time. And maybe we need just a little bit more assistance with my, I really hope no one has like photosensitivity. If you want to turn around or leave the room, that's definitely fine. So Docker has a distinction between runtime and build time. When we talk about things like Docker files or pulling images from the Docker Hub, we're mostly talking about stuff at build time. So we're actually copying our source code into the image. We're compiling that container image. That is build time stuff, pulling dependencies. Runtime is when we take that image and actually run it inside of a container. And that's another distinction that it's, as a beginner, sometimes hard to wrap your head around, is that the image is sort of like the CD-ROM of your application, and the container is the instantiation of that. So it's actually when you're running the contents of that image, that's when it becomes a container. But what you interact with, what you push to a registry, what you pull from a registry, that's all images, and that's all that's all build time. When you move on to runtime overrides build time. So any options that I pass into my container, the run command, is going to override something that I put in the build time. So if I copy a file into my image at build time and then issue a command at runtime, that's going to override it. I can overwrite the files that are inside of my container by passing in, for example, a volume that has the same file path as something that I've previously copied into my container. And that's exactly how we can access source code, is by saying, please mount the code that I have locally on my machine into the container. Even if I had stuff copied in there at build time, since I'm issuing that at runtime, it's going to overwrite those files and give me instant access and the ability to interact with my source code inside of the container. This becomes a little bit hard to demonstrate without a monitor, so here's hoping. I guess while we're waiting, how many of you are using Java mostly for your job? How many of you use Node? Any Python? Okay, Ruby? Go? Okay, cool. I love going. Okay, great. So I decided to use the Node application for my demos, and this is like the third time that I've ever touched Node code. So it was a kind of an interesting experience, but that's also maybe proof of how nice Docker can make your development experience, that I didn't really have to touch the code. I just had to touch the configuration, and I was able to get everything up and running. But we'll have a couple different examples, and most of the stuff that I'm talking about, actually pretty much everything that I'm talking about, is language agnostic. So I might be using Node for the example or Python, but it's certainly applicable if you're using Java or Golang or Ruby or anything else. Okay, there's no flickering. I think it might be a little tricky to read, but I'll take that over like, I don't know, disco dance party up here. Okay, cool. Sorry about the interruption, but we're back on track. So we were talking about build time versus runtime and how anything that you do at build time can easily be overrun at runtime, either by the actual Docker run command or by something that you declare in your Docker Compose YAML file. So in this case, I'm going to mount my source code, which is in a subdirectory called result, because I'm only dealing with the result app. I'm going to mount that into my container at -app, which is where I copied the files during the image build time. That way I can edit stuff on my local machine and see them reflected inside of the browser. So, oh great, I can make that a little bit smaller. So I just want to double check to make sure my application is running still. I'm going to use Docker Compose PS to do that. And I can see that I have a good healthy state of up for all of these. If I bounce over to Chrome, I can see that this is still up, but it looks a little bit different from the screenshot that I had in my slides. It's the wrong color. So that's maybe the first thing that I want to do, or I just want to change the colors. So I have a fancy script that's, I want to change the colors to match the DevOps world color scheme. I'm just going to run this script that's going to replace some of the hex codes in my CSS file. And that's great. So I didn't have to do anything with Docker Compose. I just edited the files. Maybe to illustrate that a bit better, I can show you a git status. We can see that I just modified those CSS files. I didn't do anything else. I didn't have to issue a new Docker Compose command. I didn't have to rebuild the image. Everything just happened automatically. I'm able to do that in the browser. I can go back and run that same script to modify those files again, and then refresh the page and see that the colors have updated automatically. So this is a very simplified example, but the normal workflow as a developer where you want to make a change, see it instantly in the browser. It doesn't really matter that I'm using Docker behind the scenes. You can't really tell. It's just that you're interacting with your code as you normally would if you were running everything locally or however you would do it before. So that's great. That's how we can access the source code inside of our container. The other thing that is really important is dealing with external dependencies and making sure that your applications can connect to them. So we have two external dependencies or external services in this application. We have Redis and we have Postgres. And if we remember back to the Docker Compose file that we had before the flickering happened, we have declared this service called Redis that's using the Redis Alpine version directly from Docker Hub. We're just pulling it down and running it. We're not actually building a container image from a Docker file. The really nice thing that Docker does for you is it will create and make that service available with the service name as a host name. So inside of my application, I can just say, I'm looking for Redis, and my host is Redis. So even though I'm using containers and it often has the feeling of being really complex and I have all these configuration files, there are some cases where it actually can be pretty easy to use. So I can just pass in that host name Redis, and because my application is running also in a container, it's all available on the same network with that host name. So I can just easily connect to that service. I could not use Redis in a container. I could just use some other instance of Redis and pass in that host name instead. Just because one part of your application is in a container doesn't mean everything has to be in a container. And I think that's particularly important for things like Redis or databases where you might want to use things that are shared with other teams, or you don't really want to go through the trouble of managing persistent data in a database and containers, and just use, for example, RDS if you're using that already. You don't need to run your database in a container. This is probably one of the, I don't want to say common mistakes, but sort of the over-ambitiousness of getting started with Docker in development is that you want to containerize everything. Persistent data is really challenging to put inside of a container. Containers are ephemeral. If you have something running in a container and that container goes away, all of the data that's inside of the container also goes away. So we don't live in a stateless world. We like to think that we do, but our applications have state, and managing state is really challenging. So one thing that you can do, and what I've done in this application, is I'm using something called a data volume. A data volume allows me to have data that exists outside of the lifecycle of my container. So my containers are ephemeral, but because I'm putting this data volume in that container, I can write data to that volume, and that volume will stick around even if my container blows up or something bad happens to it. You can use a lot of different drivers for these data volumes. You can use AWS or Google. There's tons of different drivers, but you can also use your local disk, which is what I use when I'm developing. So what this looks like is that I have declared a volume called database data down here in my Docker Compose file. And then using that same volume mounting syntax, I'm just going to mount varlib PostgreSQL data into that data volume. So that means any data that's written to that directory, my Postgres data directory, is also going to be written to the volume. And that volume is going to persist outside of the lifecycle of my container. When you issue a command to bring your application down from Docker Compose, it does not automatically destroy the volume. This is great for you as a developer because you won't accidentally destroy your database state, but it can eat up a lot of disk space, so just be aware of that and understand that images take up space, volumes will take up space, and understand what's being taken down for you and what's being persisted for you. Cool. On the topic of space, the next thing I want to talk about is optimizing images. Because images can end up being very, very big and very bloated. And it's really important that if you are going to invest some time in optimizing your development workflow, that you focus on the Docker file and sort of give that a little bit of love first before you focus on other stuff, because it is really the heart of your application. So every other thing that you do, if you want to take these container images and start running them with an orchestrator like Kubernetes, you want to start running them in production, how optimized your Docker files are and how big your images are is going to have a big impact on the operations and the operational complexity of your application. A Docker file is just a list of instructions that tells Docker, or whatever image building service you're using. Most people will use Docker. There's starting to be some smaller open source projects that are there just to build the images, but let's just assume we're using Docker. Dockerfile just gives Docker a list of instructions, top to bottom, of every single thing that's necessary in order for your application to be running. So we're going to start with a from command, and that is the base image. So for those of you who raised your hand when you said, yeah, I'm using Java or I'm using Python, chances are if you go to Docker Hub, there is an official image that's maintained by the community that governs the language or the framework. And that's available for you to consume and use that sort of as the base layer for your application, so you don't have to reinvent the wheel. Just use the official one. It's going to have everything that's necessary for your application to run already packaged for you. Once you have that layer, you can start adding the special Snowflake stuff that you need to have your application run on top of it. So in this case, this is a Node app, and unfortunately, I've lost all of my very beautiful animations, so you'll just have to use your imagination paintbrush and think about how lovely they are. But this is a Node application, so I'm going to have a from command with a Node image. And then from there, I'm just going to start listing out the instructions so that my application can run. So I'm going to install a couple things via NPM. I'm going to copy my package JSON. Then I'm going to do an npm install. Then I'm going to copy all of the rest of the source code. This is a really important thing for optimizing the cache, and we're going to see some examples of specifically why this order matters when we talk about cache optimization in just a little bit, and I'll show you a live demo. One other cool thing about the Docker file is that it's sort of like a living documentation to give other people a little bit of help if they're going to be using your application as well. So if you're on a development team and a bunch of people are sharing this, it's a good way to leave little breadcrumbs to help them understand. For example, this application is going to be running on port 80. So in my Docker file, it's pretty obvious to the person who's reading it next as they see that there's an environment variable that I left there to say port is 80, and that also we should expose port 80 right in the Docker file as sort of like a living documentation, self-documenting to help people be successful when they run your image. The last thing that I pass in is a command, and that's just the command that should start my application. So in this case, node server.js. This is every single thing that my application needs, this result application needs, in order to start running. It's all there packaged in the little image, and I can just ship that image to other people, distribute it on a registry, have them pull it down. They don't have to download all of this stuff. They don't have to do the npm install. It's just all there for them. For faster dev cycles, that image distribution and sharing, if you can make that quicker and smaller, it's going to help you optimize your dev cycles and work a little bit more efficiently. So one thing is using caching, and caching is a layer-based caching system. So at build time, anything that's been built before that Docker still has a record of doesn't need to be built again. It's going to be called a cache hit, and it's just going to skip the building. So we can see, like, if you're using node, that same node from image from node 10.9 Alpine or whatever label I had, if I'm using that for another application, I don't need to pull that again. I can just use the same thing. So I'm going to have a cache hit, and we're going to see a little output that says using cache. So the more in common that your images can have, the more shared stuff, the smaller your images will be, the faster that they'll build because of that cache reuse for every layer. The little trick that I did in the Docker file before was copying over my package.json and installing, doing the npm install before copying over all of my source code. So it's common that I'm going to change my source code. Like, that's the whole point, right? But I don't want a change of index.html to have to trigger a new npm install. That's really inefficient. So what I'll do instead is copy over the package.json and do an npm install on layers that are a little bit lower and can be shared more easily. Then if I do change something in my source code, if I change the README, for example, the package.json doesn't change, so there's no need to do the install again. So particularly for those of you that raised your hand because you're using Ruby, and you know that like a bundle install takes forever, this trick is going to save you, sometimes, I'm not kidding, an hour per project, especially during things like CI, to not have to go through that bundle install again. This is a great way to take advantage of the way that caching works in Docker to help your development cycles stay nice and lean and really efficient. I'm going to skip, unfortunately, that demo because we had those technical problems, and I want to make sure that I get you all out here on time. One trick to make your images a little bit smaller is by chaining commands. This can maybe seem a little bit unapproachable if you're a newcomer to Docker and you're reading Docker files and see these long commands with chains in them. But the reason to do that is that if you have a bunch of stuff that you know isn't going to change very frequently, in this case for Node, the npm install and the cache clean, all of the stuff related to that, it's not going to change unless my package.json changes. It's fine to kind of package that all into one chained command and on the same layer. Just the existence of more layers will increase the size of your Docker image. So if you are looking through your Docker files, if you've maybe already have stuff running inside of Docker containers and you're looking for easy ways to make things a little bit smaller, a little bit more optimized, if you notice that you have a bunch of run commands, consider chaining them together. Think about the implications it might have on your cache. But in this example, I have just the section with npm install. The example on the left with the chain commands is 10 megabytes smaller than the exact same contents, but over more layers. So maybe that 10 megs doesn't seem like a big deal for a local development environment, but when that image gets promoted to production environment, maybe you're doing, you have multiple versions of the same image, and they all have that 10 or 20 or maybe 50 megabyte difference because of that lack of optimization. You're going to run out of disk space pretty quickly, and no one likes to get paged at 3 a.m. So this is a really great way to just trim down a little bit of size on your images. The other critical thing to make your images smaller is by picking the base image wisely. Almost every single language framework or application framework has an official image on the Docker Hub. And by now, almost every one of them has something that's like -Alpine, because they're using the Alpine distro of Linux, or they have a slim tag, or they've made it sort of like a little bit lighter weight version. So if you want to use the full version of something, with just like, say, node 10. That's great. You might need it, or it's an easy way to get started, but then consider using the Slim or Alpine version. It's probably going to be about half the size. That's another really easy way to reduce the number or the size of your image. One warning is that Docker Hub shows you the size of images when you're browsing, like on the web page itself. That is their compressed size, not the actual extracted size that's going to be taking up disk space. It's very misleading. I was fooled once, so I will not be fooled again, and I don't want you to all be fooled about it. Because I was like, ooh, Ubuntu for 25 megabytes, like this is amazing. It's not. I was very disappointed in myself, and then I felt very stupid that I believed it. But that's fine. So I'm sharing that mistake with all of you, so please don't make it. A couple anti-patterns to avoid as you're kind of getting a little bit more momentum using Docker in your development workflows. I mentioned at the very beginning that containerization doesn't require an architecture change for using microservices. And I think it's very tempting to want to change too much stuff at once when you introduce containers into your development workflow. I call that simultaneous innovation. So it's like, oh, I want to start using Docker, but I have to do microservices in order to do that. So I'll re-architect everything and use Docker at the same time. The more stuff that you try to change at once, the more likely that your project's going to fail, unfortunately. So just focus on one thing at a time. So if microservices are the most important thing, focus on that. If using Docker is the most important thing, you can run a monolith inside of Docker. You don't have to re-architect everything, but try to limit that simultaneous innovation. You'll have a much better success rate the narrower focus that you have. Don't skip fundamentals like giving love to your Docker files by making those images a little bit smaller. And then don't forget other development best practices. Just because you're using Docker, it's not this magical silver bullet that's going to like fix all of your application problems. You still need to pin dependencies to versions. Don't use things like the latest tag for images, especially your from image. Those are just like floating point, like whatever the latest version is. You would never do that with a database. Say like, oh, Postgres 9, 10, whatever. Don't do it with your base images. Just because it's Docker doesn't mean that we can forget a lot of the best practices that we've learned over the course of the career. So my model for super duper container success is the first thing that you should do is just get your application running inside of a container. I don't care, take from Ubuntu, whatever TLS version, dump every package in there, just get it running, because you have to start somewhere. And if you can have it running inside of a container, then you have a good foundation to optimize on. So get that running, then think about your external dependencies, think about your database or Redis or whatever other services you have. Write that application template. Get your Docker Compose YAML file up and going. Then worry about the optimization, and then worry about everything else like orchestration. So I've seen a lot of projects and transformation initiatives fail because you have your application running in a Docker container, and like the next logical step is Kubernetes. And there is 100 things to do in between those things. And there's a lot of fundamentals that I don't want you to forget, because it's very tantalizing to kind of jump ahead a couple steps and then maybe simultaneously innovate. Cool, so we have 2 minutes left, but I will make them very good 2 minutes. Debugging tips for when you're using containers for development. Viewing log output is like the very basic debugging activity that you could do. You can access all of your logs inside of the containers. It's fairly easy. There is a nice logs command on Docker Compose itself. This is going to give you like the kitchen sink of logs. It's going to give you all the logs for every single service that you have declared in your Docker Compose file. So in the application that we've been talking about today, we have 5 services. That's going to give us all the logs kind of mishmashed together for all of those 5 services. I don't love that. I don't find it very useful. So what I do is that I use Docker Compose up/d to kind of suppress the log output in my terminal. It just gives me that nice, hey, I started your service for each of the ones I have declared in my Docker Compose YAML file. Then if I need logs for a particular service, I can pass in the service name to the logs command. I can say, for example, Docker Compose logs worker, and that T flag will give me the timestamps because they're not there by default. That is basically the same command as if I were to go to Docker directly and say, please give me the logs for this specific container. But because I'm not interacting with Docker directly, I want to interact with Docker Compose. I'm going to ask Docker Compose just for the logs for my particular service. You can do other things like tail or follow, pretty much any command or any sort of option you can pass into that logs. There are a couple things where you might want to debug Compose yourself and figure out, like, is it my service that's having a problem, or is it Compose that's having a problem? And there's a couple commands or flags that you can do on the Docker Compose command itself. You can set verbosity on Docker Compose itself. You can also set a log level for Docker Compose itself to set it to debug mode, for example. That might be helpful if you're trying to debug something. You might need a shell sometimes. And the idea of getting a shell when things are running in a container can be a little scary because it's running in a container far away from where you are. You can do it two ways. There's one way to do it with Docker Compose, which is exposing, so standard in, keeping it open, setting that here standard in true, and then TTY true as well to give you that interactive shell. That way, then you would issue a command that's Docker Compose run with those flags, and that would give you the shell for whatever service. In this case, I'm just using an Ubuntu image, but I could do this for my result service, for example. I don't love this way because I don't love monkeying around with my Docker Compose file. If I'm going to start a shell, I just want to do it with Docker directly, which is sort of an anti-pattern for what we've been discussing this whole time about using Docker Compose to manage your application stack. But I think this needing to have a shell is sort of a one-off situation and not something that I want to manage over and over again that's worth templating. You can get a shell with the -it flag, which is the logical equivalent of that TTY in standard and open. So it's just like giving you that interactivity. And then you can pass in an entry point, whether it's bin bash or bin sh or whatever you want to run. Just pass that into the Docker run command, and that will give you the shell that you're looking for. Will drop you right into wherever your code is. You can also mount a volume. A lot of the examples here, I don't know what's going on out there, but I will get you out there very soon. You can pass in that -v flag and the source target. So for example, mounting in my result code into my app directory that my result application needs. A couple other helpful Docker commands. Docker top gives you a list of all the processes in the container. Docker inspect is my favorite thing. It gives you anything you could ever want about any resource that Docker controls. So if you have an image, if you have a container and you Docker inspect it, you will get any single detail that Docker has on that resource. This is really handy if you, for example, need to find things while the container is running, like the IP of a running container you can find via Docker inspect, and there's an example of how to do that. Format, you can pass in a Go template in order to just extract one little chunk out of that Docker inspect. The other cool thing, and my final trick for you today, thank you for bearing with all the technical difficulties, is running a debugger. So I enjoy using a good debugger, just like anyone else. You can certainly use Chrome debugging tools. And the other thing is that I've started using VS Code just for the purpose of this demo to see the experience of having an IDE with a debugger, and that you can do it with Docker. So let's start out with just with Chrome and looking at my application here that's running inside of a container. It doesn't really matter because the browser's just being served this page. I can go into here and see that app.js is doing some computation for my stuff. I can set a breakpoint and interact with this debugger just as normal. It doesn't matter that I'm running it in Docker at all. So that's pretty cool and probably a pretty common thing that you're going to do for stuff on the client side. For stuff on the server side, you definitely can attach a debug process. And the way that I'm doing this, just really quickly, since I don't have the luxury of a lot of time, but I'm starting my container with an inspect flag. And then I'm just pointing it to the port that I'm exposing my debug process on, or my inspect process on. Inside of, right here, inside of that service declaration, I'm exposing the service itself, the web page on 5001, which is what we're seeing in Chrome. But I'm also publishing that port for 5858, which is that debug port. So I can fine-tune and control every single thing that I might need as a developer to make my experience great. So if I pop over to my text editor, I can see that I have server.js here. And I can just click in the gutter here and set a breakpoint for anything. And I should be able to go for dogs. And I see that everything is paused. It's not updating. I can go here. I have a breakpoint set. And I can just use the debugger and inspect the value of any variable or object that I have. So it's actually really easy. And I have to give a lot of props to Microsoft for making the experience of like developer tools just like become so awesome in the last, I would say, year and a half. They've really invested a lot in that. So this is a great example of it. There are a ton of recipes and repositories on GitHub that give you sort of step-by-step examples of debugging with VS Code in a lot of different situations, a lot of different languages, frameworks, and examples for inside of containers as well. You can kind of just like drag and drop the JSON to help you set up the debugger pretty easily. So even though you're using containers, it doesn't have to be a pain. You can still do all the stuff that you want to do, debug, view logs, have instant access to stuff, and you have the benefit of having your code packaged in a little nice thin image that's easy to distribute via a registry like Docker Hub. So you're kind of getting the best of both worlds. I hope you will try it. If you have any other questions, I'm sorry about the technical difficulties, and I sort of had to rush through some of this content, but I'll post these slides online. I'm going to hang around for a little bit. If you have questions, feel free to come up here. Thank you so much, and thanks for bearing with all the difficulties.